Hi guys, welcome to Science in 5. In this video we're going to talk about balancing chemical equations. Before we continue guys, you might want to hit the subscribe button. We've got lots and lots of videos that explain maths and science in a very straightforward and easy manner, no fuss. Alternatively, you can also visit us at our website. The details are at the bottom of this video. Okay, a chemical equation can be represented by words. Example, hydrogen gas plus oxygen gas gives us water vapor. Water vapor simply means water in a gaseous state. For example, steam. Another way to represent a chemical equation is by using symbol diagrams. Okay, we use a combination of circles that can have color, they might not have color in them, just to represent how the atoms are bonding or are bonded in different substances. In this example, you can see the two white circles bonded together, showing hydrogen gas, two yellow circles bonded together, representing oxygen gas, a yellow circle bonded to two white circles, representing water vapor, because the formula for water is H2O. The third way we can represent a chemical equation is by using chemical formula. In this video, we're going to be looking more at chemical formula, okay, as we balance equation. So we're going to use chemical formula to balance chemical equations. Okay. A quick thing about the chemical formula is that take note of the small numbers at the bottom. Okay, the small numbers at the bottom, those subscripts, they help us to identify different substances. Okay, for example, O2 means this oxygen molecule has got two atoms bonded together. H2O tells us that this compound has two hydrogen atoms and one oxygen. If you look at this symbol diagram. Okay, so the whole business of balancing a chemical equation is to ensure that the number of atoms on the left hand side must be equal to the number of atoms on the right hand side. Look at the symbol diagram that we have here. We have two hydrogen atoms on the left hand side. Jump quickly to the right hand side, there are two hydrogen atoms. Okay, when you look at the oxygen atoms, you find there are two oxygen atoms on the left. There's only one oxygen atom on the right hand side. What happened to the other oxygen atom? During a chemical equation or a chemical reaction, the number of atoms must remain the same. Atoms do not disappear during a chemical equation. Okay, so how then do we go about ensuring that the number of atoms on the left hand side is equal to the number of atoms on the right hand side? There's a systematic way that we must do. So at the onset guys, I'd like you to avoid this common mistake of adding small numbers at the bottom in an attempt to balance a chemical equation, or even scratching out the small numbers at the bottom. That is incorrect. Okay, so for example, if I added a little 2 here, by inspection it looks like the number of atoms is now balanced. Why? Because here now I've got two hydrogens and I've got two oxygens. Here I've got two of the oxygens and here I've got two hydrogens. However, this way is totally incorrect because I've made a different compound now. I've made something with a different formula to the water vapor. Water vapor is H2O. This compound H2O2 is actually hydrogen peroxide. So this way of balancing is totally incorrect. So how then do you balance a chemical equation? Well, what we have to do is to add whole numbers in front of the substances, the coefficients. Okay, so whenever you're balancing a chemical equation, the first thing you just need to do is place dashes in front of the chemicals or the substances, and then add numbers there. Okay, let's go. So on the left hand side, start from the left hand side always. I can see there are two hydrogen atoms. Let's check on the right hand side if I have two hydrogen atoms. Aha, I got the two hydrogen atoms on the right hand side. Okay, so I'll leave the hydrogen for now. Jump quickly to the oxygen. 2 oxygen atoms here. There's only 1 oxygen atom here. So what number can I put in this space to ensure that there are also 2 oxygen atoms on the right hand side? It's a 2. By placing a 2 on the right hand side, I've balanced the oxygen numbers. But that presents a new challenge now. Initially, there were 2 hydrogen atoms. By placing a 2 here, now there are 4 hydrogen atoms. So here on the right hand side, I now have 4 hydrogens and 2 oxygens. So what must I do to the left hand side to balance the hydrogens? Place another 2 there. And then this now means, if you look at the symbol diagram, I just need to add those substances and the equation is now balanced. So rule, guys, don't change the subscripts. Another rule, only add whole numbers to the chemicals in the chemical equation and play around with those numbers until number of atoms on the left hand side is equal to the number of atoms on the right hand side. Time for some practice? Yes. At this time you can pause the video and you can practice by balancing the following chemical equations. Okay, 10 equations that need to be balanced. Remember, do not change any of the small numbers. Do you see small numbers involved in these substances? Yes, your business is not to change any. Do not cancel any of the small numbers. Do not add any new small number. What you just need to do is to add whole numbers in front of each substance. Okay? So when I'm balancing a chemical equation, the first thing I just need to do is I'm going to place dashes in front of these substances so that I just quickly tell myself that I don't need to change any small numbers. My business is to ensure that I add numbers in these spaces. Okay, so let's check. There's one carbon atom on the left hand side. There's 1 carbon atom on the right hand side. So the carbon looks fine. There are 2 oxygens on the left hand side. There are 2 oxygens on the right hand side. This equation looks like it's already balanced. So guys, some equations we don't need to do anything to them. If the equation is already balanced, we leave it as is. Leave it as it is, go to the next equation. Okay, so the first equation is clearly balanced. Okay. Second equation, again, I'm placing numbers there to see if I can balance the equation. Start from the left hand side. There are 2 hydrogens here. On the right hand side, there's only 1 hydrogen. What do you think I can do here? Place a 2 here. By placing a 2 here, I hope you can see, guys. Okay, there's a 2 there. I've balanced the hydrogens. Okay, let's look at the bromine. There's 2 of them on the left hand side. Initially there was 1 bromine, but because of the 2 in front, there are also 2 of them. So this equation is now balanced. Go to magnesium and oxygen to give you magnesium oxide. There's 1 magnesium on the left hand side. There's 1 magnesium on the right hand side. There are 2 oxygens on the left hand side. There's only 1 oxygen on the right hand side. What must I do? Place a 2 here. Okay, and then by placing a 2 here, I've balanced the oxygens. Now I need to balance the magnesium by also placing a 2 there. Let's go to number 4. There's 1 lithium on the left hand side. There's 2 lithium on the right hand side. This one is going to be very interesting how we balance this one. Okay, so initially I can put a 2 on the left hand side. I've balanced the lithiums. Then I go to the oxygen. I notice there are 2 oxygens here, and there's only 1 oxygen on the right hand side. So I need to place a 2 there to balance the oxygens. But now I have 4 lithium. And now I have 4 lithiums on the left hand side. So how am I going to balance those lithiums there? Well, I need to put a 4 on the left hand side. Okay. Pen was playing games a number on me. Finally got it to work. So there are 4 lithiums on the left hand side, 4 lithiums on the right hand side, 2 oxygens on the left hand side, 2 oxygens on the right hand side. Okay, so for magnesium and hydrochloric acid, again I can quickly see that there's 1 magnesium there, 1 magnesium, fine. In fact, this equation is missing something. Let me just add there. There must be plus H2 gas. For number 5, just add H2 gas there. Okay, so I can see there's 2 chlorines here, but there's only 1 Cl there. So I need to put a 2 there to balance the chlorines, and then the hydrogens become balanced automatically. I remember one learner said to me, "How well, it looks like so we keep adding 2s most of the time." And I couldn't deny that. Sometimes to balance chemical equations, if you're struggling at first, you can try adding 2s to the equations. If that doesn't work, then you probably need to add another number. If you look at the equations we've done so far, there's a pattern. It looks like 2 is a common fellow that is coming here and again, 2 here, 2 there. But that does not necessarily mean that every equation you're going to add 2 to balance it. But it might mean that maybe 2 is a common number, is a common coefficient that is used in balancing chemical equations. Number 6. Number 6 is now quite interesting. How would we balance an equation like this? Well, there is no obvious pattern that we can see here. Okay, for example, if I say there's 1 carbon on the left hand side while there's 1 carbon on the right hand side, fine. Then there's 1 plus 2 oxygens on the left hand side, that's 3. And then there's 2 oxygens on the right hand side. What can I do? Well, if we use this idea that we've just spoken about of trying out the 2, what if I place a 2 there? Now I've got 2 carbons on the left hand side, so let me place a 2 there to balance the carbons, right? So let's check if the oxygens, how am I going to balance them? Now I've got 2 times 1 oxygen, there are 2 oxygens, plus another 2 oxygens here, so that's a total of 4 oxygen atoms. Here I have a total of what? 2 times 2 to give you 4 oxygens. So guys, another trick that I'm hoping you're seeing as we go along with balancing equations is to calculate the number of atoms that are involved when there's a coefficient and there's a subscript. You multiply those numbers. Multiply the big number with the small number. It will tell you the number of atoms. For example, how many oxygen atoms are here? Well, 2, little 2 times big 2 is 4. Okay. Number 7. Okay, there's 2 nitrogen atoms on the left hand side. There's only 1 nitrogen on the right hand side. So So by placing a 2 on the right hand side like that, I've balanced the nitrogens. Okay, now I've got 2 times 3 of hydrogen, which is 6 hydrogens. I've got 2 hydrogens on the left. What number must I place here to have 6 hydrogens on the left? Is 3. Then that equation is now balanced. Number 8, SO3, H2O, H2SO4. Did you guys see that this equation is already balanced? Yes, this equation is already balanced. 1 sulfur, 4 oxygens and 2 hydrogens. Number 9, P4 plus O2, P2O5. There's 4 of the phosphorus here. There's only 2 of the phosphorus on the right hand side. So what number must I place here to balance the phosphorus? There's 4 here and there's only 2. I need to multiply by 2. Once I've multiplied by 2 now, there's 2 times 2 of phosphorus, which is 4. Now there's 2 times 5 of oxygen, which is what? 10 oxygens. Okay. If you go back to example number 6, we said there's 2 times 2 of oxygen, that was 4 oxygens. If you go to number 7, the hydrogens, how many hydrogens are involved here? There's 2 times a little 3, which is 6 hydrogens. In the same way, you're going to have 2 times 5 of oxygen, so you have 10 of the oxygens here. What number must I place here to have 10 oxygens also on the right? Because they are multiplying each other. I only have 2. So 2 times something equals 10. 5. So 5 times 2 is now 10. I've got 10 oxygens on the left, 10 oxygens on the right. Now number 10, a little bit tricky, but I hope you guys figure it out as well. 2 oxygens on the left, oxygen gas. O3 is another form of oxygen called ozone. Found it plenty of this gas in the ozone layer. Okay, what do you think we can do here, guys? 3 oxygens on the right, 2 oxygens on the left. Remember, we can't scratch the small numbers. We have to add numbers in these spaces to balance. If I added a 2 here, it won't work, because that will mean I'll have 2 times 2 on the left, 4. There's no number that I can add here to get 4. What do you think I should do here? Okay, I need to add a 3 here. So that means I now have 6 oxygens on the left. And then here I add a 2 there. I now have 6 oxygens also on the left hand side. Okay, that's how you can balance chemical equations, guys, by making sure that you add numbers or coefficients in front of the chemicals involved in the chemical equation. Okay, once you do that, you find that you can easily balance equations. It's a trick or a skill that needs time to perfect, so don't quickly want to get it in the instant, but give yourself some time to grasp it slowly as you move along, and sooner or later you discover that balancing chemical equations is not as tough as it seems at first. Okay, alright guys, thanks for watching. Don't forget to hit the subscribe button if you haven't already subscribed. We'll see you guys around next time. Thanks for watching.